I have a feeling that those graphs are going to be peaking for the next 20 minutes. I think it's a requirement that we have a multicast talk every couple of nanoseconds. So that's what this talk is about. I only have 20 minutes, but I have about 60 slides. If you can make it out in the slides, there's actually, the titles will be either blue or red, and the ones that are blue I'm actually going to stop on, and the rest I'm just going to skip, and those will be for posterity and for your reference. So to give you kind of an idea of about multicast deployment, and not to encourage it or discourage it at all, but to illuminate what some potential problems might exist or how widespread they might be for multicast today. Looking at Marshall Eubank's excellent site on status of multicast, we see there's about 450 ASNs that are advertising approximately 7,500 MBGP routes, that is NLRI equal to 2. It doesn't sound like a whole lot, but when you actually extrapolate that out, it actually comes to almost 250 million addresses, which then actually sounds like quite a bit. But if you really think about it, really all that tells you is reachability to really borders at the AS. What you really would like to know is what multicast interfaces are enabled within the AS, and it's probably much, much lower. So we don't really have a good idea of really how widespread coverage is, at least on the global internet. On the converse too, it might also be that there's a lot of organizations, and I know at least a handful, particularly cable TV providers, who do multicast for their video over IP content that tend not to actually advertise that sort of thing out to the public internet either. You can also look at something called the source announcements, the SAs in the MSTP tables found on the internet, and that might give you an idea of how large or not multicast is being used today. And if you kind of remove some of the junk, which would be scans or just mistakes, misconfiguration, testing, you might come up with about 1,300 SAs being announced, which is a pretty good number. I don't know how many of those you would actually, any of us would actually use, maybe just a very small handful out of that, but certainly at least legitimate source announcements that are out there in the tables. I'm actually kind of curious if those stats match up at all with the operators here in the group. Just by show of hands, how many of you do some multicast, even if it's not interdomain or MSTP, but maybe do some video over IP at all? Anyone just raise their hand? Okay, so that's close to 5 or 10%, so 20 minutes is more than enough. So if you're thinking about it, then even for a few providers, cable TV, DSL providers are thinking about video over IP. Some of this might matter because by default, unless you do otherwise, just by enabling multicast, you get a host that can send to any group and a host that can receive any group. Now there's certainly flooding issues with that and eavesdropping issues. I'm not too concerned about those. The issue for this group here, the people in this room, is that of network control state. For the most part, it's quite a bit different than unicast. And unicast, the only thing that you have where hosts actually induce network state in your network is with bridge address tables, learning where hosts are on ports, and ARP tables. At least those are the only two I can think of. But if you were to imagine that hosts could actually inject BGP routes into your network, that sounds like a pretty scary thing, but that's essentially what happens with multicast. Hosts actually instantiate network state. And so it's a kind of a dangerous thing, in particular where most people who do multicast tend to have their multicast protocols all running on the same routers that the unicast routing protocols are running on. So if you end up having a problem with your multicast infrastructure, it can very well take down your unicast infrastructure, and we certainly have seen that in the past. So there's two areas of concern. There's the open receiver model and the open sender model, and they both have similar related concerns. In the open receiver model, a host signals interest in a group by sending an IGMP message. That first hop router will maintain state for any groups that it knows that there's interest for on that interface, so you have that one table there with IGMP. You also typically get at least a star comma G, that is any source, any group, and a specific source and a group state on the interface. You probably also get additional PIM state upstream towards your rendezvous point, as well as any state needed to get to other sources and receivers. So just by the simple joining of one host to a group, you end up getting multiple instantiations of state in your network. So potentially not good if someone was to actually create a havoc for you. Then you have layer 2 devices that have to do a lot of work. Unless you want your multicast to be flooded to all ports, like if you just had a hub, typically most people are deploying switches today that have IGMP snooping built in. And to do IGMP snooping actually requires quite a bit of effort. You need to look at all the packets going by, so there's a layering violation. You need to be looking for IGMP queries and reports. You end up spoofing those. You got to maintain the port to group address tables. So there's a lot of effort there, and if your edge switches aren't up to the task, they could fall over. And then just as an example of a flooding issue, if you have an interested receiver asking for specific groups, maybe one or more, but its receive path capacity is less than the capacity that the group sending rate is, then there's an obvious flooding issue there. So how do you actually deal with something like that? How do you control group membership or the rate a group sends or receives? And similar kinds of things in the open sender model. You have, anytime someone sends a packet to a multicast group, the first time that happens, your PIM DR router, your designated router, has to take that packet, encapsulate it in a unicast packet, and send it up to the RP. So that's processing workload twice. You have to do it at the DR, and then you have to de-encapsulate it at the RP. So that's quite a bit of effort just to get multicast to happen. And then again, you have PIM state that happens around the network. You get packet replication to get the packets to be flooded out to all the groups where there's branches. Most hardware might not have a problem with that generally, but there's certain cases and certain types of hardware where that's a CPU pump to do that packet replication. And then another issue with control state in the sender model is you have MSTP. If you're doing interdomain peering, or if you're doing peering between PIM domains, you have to keep track of sources between these PIM domains, and you do that using MSTP. And MSTP is just a simple flooding protocol that simply takes any source group tuple and just sends that on as a flood to all the other MSTP speakers. And so you can imagine the issues you might have there, because you can have any combination of a source address and a group address. So your MSTP messages could grow exponentially. And then as an example of a flood style attack, if you are a sender and you could send to a widely dispersed, well-connected multicast group and actually solicit a response from all those group members, you have a potential there for a nice Smurf style attack, especially so if you can spoof that source address. And so all these are issues in the kind of the default multicast model that's been being deployed for the last few years. So really quickly, to give you an overview of the 224/4 address space, the first /24 in this net block is really for link local only. You don't have to do anything. Routers by default today won't forward anything that's to this destination address for things like router protocols or PIM hello messages and that sort of thing. There's a whole bunch of space that's reserved, a bunch of /8s, in fact, quite a bit of it. And then there's something called SSM. I won't really talk about other than to say it's widely to believe this is a little bit of a savior for multicast. It's probably not true. There's not really much deployment yet. It remains to be seen if there'll be a lot of deployment. But the jury's, I think, is still out on that one. And then there's something called glop space, which is really a way for anyone who has an AS to get the equivalent of a /24 multicast block to use however they wish. And then finally, the administratively scoped block is somewhat akin to our C1918 address space. For our purposes here, the thing you really need to know is that these addresses shouldn't exist in any tables or be transited through the public internet. So if we think about that for a second, some people like to do bogon filtering in unicast. Can we do the same thing in multicast? And the answer is, yeah, sure, you can do that. It's a little bit of a pain in the butt to do it, and it's somewhat questionable how much value it buys you, but you can certainly do it. You can reduce the support of multicast addresses by a pretty large fraction of the overall address base. So, and the one reason that you might want to do that is just get rid of noise. There hasn't been as many lately, but there has been worms that scan all the address space, 0/0, right? So if it starts scanning the multicast address range, that does cause some problems in creating some of the state. So if you can reduce some of the packets that head into that address space, you can reduce some of that noise. But as you see in some of the other slides, it's of worthy deviance to actually do a lot of maintenance on those filters. And here's just a quick graph to give you an example of what the filtering effects might be. I didn't put the legend on here, but on the left-hand side, the y-axis is the number of SAs as seen in a handful of routers on the internet. The top line is probably a little bit hard to make out. The yellow line is actually one of the Abilene routers, which probably sees as good of MSTP table as anybody, and the other just some other routers I had a view into. And along the x-axis is what sorts of filters are applied to this MSTP table. So starting from the left, there's no filter. So you might see about 2,800 MSTP SAs today. And if you apply just the 239/8, you decrease some. Some people are sending to that address space for whatever reason. But the real bang for the buck there is just getting rid of all those /8. So it's quite a significant savings. It's like 40%. Then you can go a little bit further, get a little bit more anal, do some more specific filters within some of those other /H that you might pass, and get it down a little bit further. Okay, so there's a lot of junk out there today. Even without having to try to do too much, you can actually reduce those tables quite a bit. So what sorts of protocols are valid to multicast destinations? You've got UDP is kind of the ubiquitous one. That's kind of where all the content happens. UDP is the one that's typically forwarded through routers, although you probably wouldn't be apt to see a UDP packet to a multicast destination with either probably a source or destination port less than 1024. So if you were inclined to do some filtering, you could look at some statistics like that and see if it would be valid to do some filtering there. Pretty much everything else that I know of, for the most part, tends to stay link local only. So that includes IGMP, PIM, routing protocols, and so forth. And I put a question mark for ICMP, and I'll come back to that in a second. TCP should be a no-brainer. That one, there's no legitimate reason for TCP to actually be set up between either a source unicast and a multicast destination or vice versa. However, in some tests that I've done, I've been able to see that Solaris will actually respond to a TCP SYN packet if you send it to a multicast address it's listening on. Even more curiously, one of the router vendors, Cisco iOS, will respond to an ACK with a reset, which is not the curious part. The curious part is that it will actually put in the source address field the group address that you send to. And that just seems really broken to me, and I don't know why they do that. And I've been trying to convince them that's just broken and they should change it, but it remains to be seen if they'll do it. So TCP should probably just be filtered, at least at the edge anyways. But if you do see attacks against your infrastructure with the same multicast address as the source address, you know someone's been harrowing a bunch of Ciscos. So ICMP is one that's technically legitimate to send a multicast address space. So if you send ICMP packets to a multicast destination, it's much like sending it to a broadcast address. So while technically legitimate, there is a very large amplification attack potential here. Many systems do respond to multicast pings. And in fact, in some of the tools that we've created and tested this, from one vantage point, you can send out one ICMP ping, and if you know the right group address to pick, you'll get over 2,500 responses in today's multicast-enabled internet. That's quite a lot. And if you think about that, most of those hosts tend to be to well-connected universities or other sites. That's a lot of packet potential there, so I would argue that most people should be filtering that. Again, to a little bit restate some of the things I talked about at the beginning, IGMP is kind of where the first network control state happens. That's when a host signals to the router that it's interested in receiving or participating in a particular group. So for each group, on each interface, the router has to keep track of. And of course, there's timeouts associated with that. But potentially, a router interface would have to keep track of 224/4 addresses. Okay? And in turn, whenever you create an IGMP report, that would typically instantiate at least one star comma G and one S comma G in that router on that interface. But most likely you'd get additional PIM state on other router interfaces upstream to other points in the unicast, the unidirectional multicast tree, as well as other routers up towards the RP and other sources and senders, or other sources and receivers. I think I mentioned this pretty much already. The IGMP snooping switches have to do quite a bit of work, both in terms of looking at packets and building the port to address tables. It has to spoof IGMP messages back to the router. It has to actually figure out who is the router to be able to do that. So there's a lot of effort, a lot of trickery going on there. A lot of people don't seem to like IGMP snooping switches that much, probably for good reason, not just that because it's a layering violation. So again, more PIM state stuff. This is the one that's potentially pretty dangerous, at least within your intradomain, within your PIM domain. The one additional thing to mention is the register messages. That is, whenever a sender sends a multicast packet, the first time that happens, and potentially more times after that, it'll get encapsulated up to the RP. And then there's that decapsulation effort. So there's quite a bit of work to actually make multicast happen. And MSTP is kind of the big one that a lot of people seem to pay attention to, probably because it's interdomain, and so the effects of someone else's noise reaching your site is usually where this ends up. Each sender group pair is what creates an SA message. So one host sending a packet to one group, that's one SA message. One host sending to 10 different groups, that's 10 SA messages. So you can extrapolate all that out. The potential number of SA messages can get quite large if you're not careful. And again, there's some encapsulation, decapsulation effort that might happen here with MSTP as well. And MSTP runs over TCP, and so it has some of the same kind of issues with BGP in terms of TCP session resets that we've heard about in the last couple of years. And MD5 is available for MSTP in both the Cisco and Juniper routers, but I don't know anyone that actually uses it yet. I would use it, but if anyone from Force 10 is here that is interested in implementing it, I'd appreciate it. So when MSTP storms originally started happening a few years ago, it was because worms were scanning the 224/4 address space, probably by mistake. And so this creates big floods of messages that go out to all the MSTP speakers of the internet. And that's not good because that affected a lot of people who had MSTP on really their core border routers. And because of the resource consumption, they started to melt and fall over. And so the first solution to that problem was to create a simple rate limit for SAs. And you can apply that based on an MSTP peer itself. It's sort of like applying a prefix limit on your BGP routes, which works, although it's still potentially a problem because really any host could fill that limit pretty quickly and then starve out all the other traffic. So you need a little bit more than just a single rate limit per peer. One nice thing that Juniper has, and I don't think Cisco has it yet, is a per source rate limit. Of course, this requires resources to manage this, but this prevents some of that host is infected scanning the 224/4 problem. So after hearing all these problems with state and potential issues that you could run into in melting your network if you get too much of it, you may be afraid to actually turn on multicast if you don't have it now, or you may be considering turning it off if you have it enabled. But one thing you can do for people who are interested in the sort of applications like video over IP, a lot of cable providers would do this sort of thing, is you can still run a multicast network pretty safely by doing the following. On all your router edge interfaces that face your end host, your end customers, just filter everything to 224/4. Don't allow anyone to send you IGMP or any UDP packets or anything at your edge interfaces. Okay, so then what you do is, let's presume you're doing video over IP and you've got different channels associated with a group address. So then you take those group addresses and then you just statically join them to that router interface, which you can easily do. Now you have to keep in mind that all the number of groups that you're going to statically join have to be able to fit out that router interface if they're all sitting at once, and you have to of course allocate enough capacity for any unicast traffic that you want to support. But then the magic still happens on your layer 2 infrastructure. Let's say you have IGMP snooping switches. They still manage all the joins and the leaves and all that other stuff and manage the port to group address database on that switch. And presto chango, you've got yourself a receive-only model, kind of like SSM, without any of the problems of host creating state in your network. So all the state that you've created is state that you've set up, and that's the only state that's going to be there. Of course, if you do MSTP, you still have to protect that a little bit. So now the one thing I want to throw in here, hopefully any router vendors that might pay attention, or anyone who maybe shares some of the concerns about some of the knobs that aren't there yet with multicast, some things that might be nice. We have authentication in BGP and we have authentication in OSPF. We don't have authentication in PIM. Actually, I don't expect that we'll get it now. It's probably too late, but it would have been nice if that was built with a nice, easy shared MD5 secret a long time ago. Something that might be kind of nice is an IGMP source rate limit like Juniper has with their MSTP source announcement rate limit. If you want to maintain somewhat of an open receiver model, this might be kind of handy. And something I mentioned in last year's botnets talk that I think might be worth trying out is this idea of a rate limit for flows. So if you had a rate limiter based on the source address for flows, that could potentially stop lots of things that you might want to stop, like scanning. I know some of you are really putting up with a lot of headaches for peer-to-peer. It might slow down that stuff a little bit, or at least be a useful monitoring tool. I don't know how much resources that will take, probably a lot, but I'd like to see something like that. I think it might be an interesting knob to try. I know some packet shaper boxes do that sort of thing. Managing multicast filters is a real pain. There's no good way to do it other than manually updating your configs. And certainly you can script all that stuff, but they tend to change quite often as groups are found out to be common noise pool or I guess swamp multicast space. Being able to have some kind of like a bogon route server for multicast, and it would be nice if it supported all three protocols, IGMP, PIM, and MSTP. That would be a handy thing to have. And because not too many protocols actually are being forwarded through routers that are multicast, or protocols that were designed solely for multicast like IGMP, it seems to make sense to not have to actually forward those through the router. So if you had like a no IP forwarding knob for IGMP, you could basically disable certain protocols or certain protocols to multicast address space from being sent past an interface. And speaking specifically to Cisco here, that 2500 plus number I mentioned earlier seems to be mostly Cisco devices. So turning off the multicast echo response would be nice on Cisco. And then lastly, something other people have talked about for a while is having a passive interface mode for PIM. When you enable multicast interface on routers today, by default your interface is listening for PIM messages and it'll set up neighbor relationships. And this is not a good thing. If you have end hosts essentially trying to become PIM routers, they might take over the DR function or start sending you assert messages. So you want to basically set up multicast on interface, but kind of really disable processing of any other PIM messages on that interface. Now the next three slides I actually had to just kind of invent. I have no experience in a real actual multicast specific attack that someone has intended to do, other than the things I've just tried to do with some custom built tools. So I'm kind of guessing at this, so if there is actually ever an actual multicast attack, I don't know how well this stuff actually works. But let's presume that you want to try to keep your multicast infrastructure up for some period of time. So that would mean avoiding taking things down like the RP or some of those core devices. Of course, in the sender and the receiver model, it would be best if you had access or close to access that source host, and you could just disable that or somehow filter that out. But you can do scoping on multicast and filter packets to specific groups. You could certainly turn off PIM on an interface level that's facing the host that has a little bit less collateral damage than actually taking down something like an RP. And something I haven't tried but I think might work is if you have a specific group that's being attacked, you should be able to change that group to point to a different RP, and then effectively you could point that RP into a sinkhole or a black hole. And similar things here for receiver-based attacks. You have to pay maybe a little bit more attention to IGMP if you want to solve the problem that way. And the one that most people seem to put more focus on is the inter-domain attacks. You can do a pretty good job of relieving these as well. And the big thing here is to do the filtering on the SAs typically by source who is generating those SAs. I don't think you can do originator today. That might be a nice option. But if you're actually getting attacked by kind of a net block as opposed to a single source, you could remove that net block from your MBGP route, and that should effectively disable that from getting to you as well. So finally, the one thing that makes multicast not so bad or no worse than it has to be is that you can actually mitigate a lot of the problems in terms of the network control state and forwarding of multicast packets yourself. You don't have to rely on others to run a clean multicast network to actually have that stuff not propagate to your infrastructure, just by using filtering of SAs and other sorts of things. So that's, I guess, kind of the good news. And I think we have filled our multicast talk quota for the next couple of years. Are there any questions?
Tom Pusateri. If you set the PIM hello interval to 0, it gives you that passive interface that you're looking for.
I'm sorry, you said the PIM what?
Hello interval.
Hello interval. Okay, that's good to know. Thanks. Okay, if anyone else has got my email.